Hi, my name is Melanie and I'm going to talk about electricity and magnetism. Electromagnetic force is a branch of physics involving the study of the electromagnetic force, a type of physical interaction that occurs between electrically charged particles. The electromagnetic force is carried by electromagnetic fields composed of electric fields and magnetic fields, and it is responsible for electromagnetic radiation such as light. It is one of the four fundamental interactions, commonly called forces, in nature, together with a strong interaction. The weak interaction and gravitation at high energy, the weak force and electromagnetic force are unified as a single electroweak force. The interactions of electricity and magnetism are difficult to explain in non-technical terms. This is primarily because one must describe the interactions in terms of visible force fields, which shift, expand, contract, strengthen, weaken, and rotate in space, and these are very difficult to describe adequately in verbal terms. In mathematical terms, coupled sets of three-dimensional vector differential equations are required, and these are also quite difficult to visualize. Originally, electricity and magnetism were considered to be two separate forces. This view changed with the publication of James Clerk Maxwell in 1873, a treatise on electricity of magnetism, in which the interaction of positive and negative charge were shown to be mediated by one force. There are four main effects resulting from this interaction, all of which have been clearly demonstrated by experiments. Electric magnetism. Electric charge attract or repel one another with a force universally proportional to the square of the distance between terms. Unlike charge attract like one repel. Magnetic poles or states of polarization at individual points attract or repel one another in a manner similar to positive or negative charge, and always exist as pairs every north to pole. Like if the two are negative, is one repel, and if one negative and one positive, is one to attract. An electric current inside a wire creates a corresponding circumference magnetic field outside the wire. Its direction clockwise or counterclockwise, depending on the direction of the current and the wire. A current is thus of the loop of wire in which move toward or away from magnetic fields, or a magnet is moved towards or away from it. The direction of current depends on the fire of the movement. The weak nuclear force, which binds to all known particles in the Standard Model and causes certain forms of radioactive decay, in particle physics, through the electroweak interaction and the unified description of two of the four known fundamental interactions of nature, electromagnetics and the weak interaction. The strong nuclear force, which binds quarks to form nucleus and binds nucleons to form nuclei, the gravitational force, or all other forces, are derived from these four fundamental forces. The electromagnetic force is responsible for practically all phenomena one encounters in daily life above the nuclear scale, with the exception of gravity. Broadly speaking, all the forces involved in interaction between atoms can be explained by the electromagnetic force acting between the electrically charged atomic nuclei and electrons of the atoms. Electromagnetic force also explains how these particles carry momentum by their movement. This includes the force we experience in pushing or pulling ordinary material objects, which results from intermolecular force that act between the individual molecules in our bodies or those in the objects. The electromagnetic force is also involved in all forms of chemical phenomena.